All right, so here's some help with number 10 and 12 on the problems here. Number 10 is one coin is flipped 4 times. What's the probability of flipping 2 heads and 2 tails? Exactly 2 heads and 2 tails. This is, let's see. No. In our notes, no, that's exactly two. Oh, it's this thing. It's this Bernoulli process, which is actually probably a little easier than they make it look. I did it in class. It's a little crazy. It looks crazy at first, but I'll show you. It's easier than you think. So if one coin is flipped 4 times, okay, it's important to know there's 4. I need 2 of them to be heads. So when you do your problem, here's the formula you'll use if you ever have, how many times out of here will I be successful? You have this thing times the probability of success raised to the number of times times the probability of failure times the number raised to its number of times. This is our little formula. So what the heck is NCR? Well, basically, this is the number of times you experiment, and this is the number of successes. So in this problem, if a coin is flipped 4 times, I have 4 flips, and I want to choose 2 of them to be heads. So you do 4, choose 2. The reason you have to do this is it doesn't say like the first 2. It doesn't say it goes, oh, heads, heads, tails, tails, or heads, tails, heads, tails, or heads, tails, tails, heads, right? So it could happen in any order. This accounts for the fact that it could happen in any order. And if you want to find it on this calculator, it's under probability. Let's see it. Boom. Now on this calculator, you actually have to type in the 4 and then the choose thing. 4, choose 2. There's basically 6 ways you could get 2 out of 4. Now if you do it on your other calculator, which is a graphing calculator, let me get my graphing calculator here as I drift away. So that's under math. See the math button? Boom. And if you see probability right there, boom, boom, boom. See them? This one's a lot nicer to type in because you can actually type in 4, choose 2. Same answer. Okay, so we got that part done. Now, the probability of success raised to the number of times you want it to happen. Now, with a coin, it's not super exciting because it's a 1/2 chance that you're going to flip heads, and it's a 1/2 chance you're going to flip tails. So in this case, here's heads. Now, how many times do I want that to happen? Twice. And then the probability it's not heads, which is 1/2, raised to the number of times I want it to not be heads, 2 out of 4. And if you multiply all those together, you get it. This would be a much more interesting problem if it was like rolling a die. Because if you roll a die, the probability of getting like a 5 is 1 out of 6. So your probability of success would be 1 out of 6. Your probability of failing would be 5 out of 6, because 5 of these are not the number I want. Okay, that's neither here nor there. So I'm going to do 4, choose 2 times 1/2 to the second squared times 1/2, put it in parentheses, it's just a good idea, squared. And you get 0.3775, which is a, let's round it to 38% chance, right? Okay. This one here is more of an and question versus or. You can check your notes. It's pretty straightforward on, like, if you have more than one event, you multiply their individual probabilities. And or you would add them. But this word says and, or both rolls. And then we get to the last question. The last question, number 12, is a lot like, let me jump back to that. Boom. Number 12 is, I always think of it as like a weighted grade kind of question. If you want a good example of one that's just like it. It's with the LCD screen. They have 3 different companies. Each one makes a different amount of components, and this percentage is defective from each different place they make it. So basically, if you said, what's the probability the screen is from vendor A, knowing that it's defective, there's a little symbol for that probability. It's probability of A given that D has already happened. Okay, so, oh geez, this didn't come out well. Gosh darn it. So if you already know it's defective, you can already figure out how many of the original problems, or how many of the original screens were defective, because you can multiply it by how many of the products were actually made at that place. So it's a pretty crazy formula. The probability of A times the probability of D given that it was A over all their probabilities multiplied together and added up. Alright, so in this one it says, okay, so the manufacturer receives frames from 3 companies. What's the probability that a defective frame was manufactured by company 3? Well, you can't just say 27 or 0.27 or 2.7% because they don't make all the glasses. If they made 100% of the glasses, I would say, okay, it's about a 3% chance it came from them. But if you think about it common sense wise, 62% of the glasses are made here, and 2% of them are defective. 30% of the glasses are made here at factory 2, and roughly 1% of the glasses are defective. And here, only 8% come from this third factory, and only 2.7% are defective there. So this says, what's the probability a defective frame was manufactured by company 3? First of all, that's going to be the probability that it even came from plant 3 times the probability it was defective at plant 3. Okay, that's the 8% times the 0.27. And that has to be over your total. The downside is the total, it's kind of like a weighted grade. You'll take the percent times their defects plus their percent times their defects plus their percent times their defects. So you're going to, I mean, it looks worse than it is, especially when we write it like this. But basically, you're taking the 3 times their defects plus probability it came from 2 and their defects, defect given 2. And then lastly, you're going to have, what if it came from factory 1? The probability it was even from factory 1 times the probability it was defective if it came from factory 1. So basically, I mean, it's not too crazy. Just turn these into decimals. 0.08 is 8% times a defective rate of 0.027. That's the probability it was even from there and defective. And now I got to divide it by the totals, which is the 0.08 times 0.2027 plus the 0.30 times 0.013 plus 0.62, 62%, and only 0.20 or 02 are defective there. So basically you got like all the defective, total defective down here, and defective from plant 3 here. So I'm going to crunch those numbers. I'm going to use the fraction button just so it's easier to see. 0.08 times 0.027 on top, and then the bottom is going to be filled with this. Let me pause it. Okay, so here we go. We got this in here, and we hit enter, and you get 0.117. So 0.117 is about 12% chance that the defective frame was actually from these guys. Anyway, that's kind of how you do those. It's a little irritating. This would look exactly the same if you asked me the same question, but about factory 2. The only thing that I would change is the top. Factory 2 would be 30%, so 0.30 times its rate of defect, which is 0.013. So that's all that would change. It's very much like a weighted grade, but it's a weighted grade for defects, basically. Hope that helped. Yeah, good times, man. Good times.